Hello, this is Gregory Maxwell, and in this lesson we will talk about solving rational equations. Solving rational equations, that means equations that involve rational expressions on one or both sides. Now we're going to get straight into the solving of these equations, and I'm just going to review the steps quickly here. Very simple. To solve a rational equation, the first thing you want to do is identify any domain restrictions if possible. To do that, you want to factor the denominators of all the rational expressions present and then identify the any values of the variable for which the expression is undefined. So if, for example, if a value of the variable causes to have a zero in the denominator, then that's a domain restriction. The variable is not allowed to be that number. Next, we find the least common multiple of the denominators, also shorthand LCD, least common denominator. And then you multiply both sides by the least common denominator, and that will simplify, and that will cancel all denominators, leaving us with a relatively simple equation, typically linear or quadratic, sometimes a little bit higher degree, but usually easy to solve. And then once you've finished solving your equation, you check your answer. So we'll start with this example over here, taken from the book Intermediate Algebra, second edition by Miller, O'Neill, and Hyde. And this question is asking us to solve this equation here, y over 4 minus 1/2 equals to 2 over y. Now, if we look at the denominators here, we have a denominator of 4, 1 of 2, and 1 of y. Since this is a rational equation, we realize that a domain restriction is that y cannot be 0. So if we ever get 0 for y, then we cannot use that as a possible solution because y is not going to be able to be 0 because then you'll be dividing by 0 on the left side. Now let's find the least common denominator. We look for the least common multiples of the numbers, which is 4. And then look for all the variables to the highest degree that they're there. Y. 4y is the least common multiple. So what we're going to do now is multiply both sides of the expression by 4y. So I'm going to multiply the left side by 4y and the right side by 4y. Now, since this is a subtraction, we're going to be actually distributing the 4y to each term. And what I'm going to also do is write this 4y as 4y over 1 when I multiply by a fraction. On the right side, the y's cancel, and then the 4 times the 2 gives us 8. On the left side, let me just show a little step here. That gives me 4y squared divided by 4 minus 4y divided by 2. Let me write that in the correct color here. So when I distribute the 4y, I get 4y squared over 4. And as you can see, the 4's will cancel. And 4y over 2, as you can see there, the 2 will cancel with the 4, leaving 2 behind. And then over here, we had 4 times 2, which would give us 8. So when I simplify this expression now, I end up with y squared minus 2y equal to 8. Now I need to solve this equation. I'm going to solve it relatively easily. I'm just going to factor this equation. So, well, before I factor it, I have to rewrite the expression in standard form. So I'm going to move the 8 to the left side. And we have y squared minus 2y minus 8 equal to 0. Then what I'm going to do next is I'm going to solve this equation by factoring. We need two numbers that multiply to be negative 8 and add to be negative 2. Those numbers are positive 2 and negative 4. So we set each part equal to 0, y plus 2 equal to 0, and y minus 4 equals to 0. And then we solve to get y equal to negative 2 or y is equal to 4. So those are our two possible answers. What I'm going to do on the left side here, I'm going to check my solutions. So let's check the solutions here. We have y over 4 minus half is equal to 2 over y. Now, if y is equal to negative 2, then we have negative 2 over 4 minus half equal to 2 over negative 2. Negative 2 over 4 is negative half. Negative half minus half is negative 1. And on the left side, 2 divided by negative 1, 2 divided by negative 2 is negative 1. So that answer works. Now let's try the other one. Y equals to 4. So now we have 4 over 4 minus half equal to 2 over 4. And that's 1 minus half, and 2 over 4 is half. 1 minus half is half. So both work. So it turns out this equation has two solutions. So our correct solutions are negative 2 and 4. Those are the possible values of y that will make this equation work. Now we'll go on to do a number of examples and see what we can get from that. And remember to follow the steps for solving a rational equation. Our next equation is 6 over x plus 2 minus 20x over x squared minus x minus 6 is equal to x over x plus 2. We're going to solve this, but before we do that, we're going to factor all the denominators and then identify any domain restrictions. So, in fact, whatever denominator doesn't factor, I'll put it in parentheses. And then, as you can see, this is a quadratic that can actually be factored. We need two numbers that multiply to be negative 6 and add to be negative 1. So those numbers will be positive 2 and negative 3. And then on the right side, that doesn't factor either. So we have x over x plus 2. And now we're going to look at our domain restrictions. We see here that x is not going to be allowed to be negative 2, nor is it allowed to be positive 3. If x is any of those numbers, then we cannot use those as an answer because then you'll have 0 in the denominator. And also the least common multiple of the denominators, LCD. We have x plus 2. We'll go over here. There's an x plus 2 as a factor already once. And then there's another x minus 3. So we're going to multiply that in. And that x plus 2 is also already covered. So the least common multiple of the denominators, the LCD, is x plus 2 times x minus 3. So what we're going to do now is we're going to multiply both sides by the common denominator. Now in doing that, we're going to have to multiply each term because as you see from the previous side, when you multiply both sides, if there's an addition or subtraction, you distribute to each term. So I'm going to kind of skip the one step here, just slightly. And just go straight to multiplying the common denominator to each term. So, I should have left this in factored form. X plus 2, x minus 3. And while I'm writing this, I just remind everyone to make sure you write your letters and numbers clearly so that there's no ambiguity. If you have a 2 and a z, make sure your z does not look like a 2. And if you have a 7, make sure it doesn't look like a 1, or your 1 doesn't look like an L. So we're going to multiply both sides now by the least common denominator, x plus 2 times x minus 3, which really means we're multiplying each term by the least common denominator, x plus 2 times x minus 3. And we're doing that on both sides, because in an equation, whatever you do on one side, you need to do on the other side to keep the equation the same. Now we cancel. X plus 2 cancels with x plus 2, and that's the expression. X plus 2 here cancels with this x plus 2, and x minus 3 cancels with x minus 3, and again x plus 2 cancels with x plus 2. So what we end up with is 6 multiplied by x minus 3 minus 20 times x, that was always left. And then on the left side we have x times x minus 3. So now we distribute and solve the equation. I'm going to draw my little arrows here to show my distribution. And I'm going to write this here. We have 6x minus 18 minus 20x equals to x squared minus 3x. We need this whole expression to be all equal to 0 because it's a quadratic equation. So I'm going to move those things that are on the left side to the right side and combine like terms. So I have an x squared. 6x minus 20x is negative 14x. But then when I add the 14x to both sides, well, let me simplify down here to show you what I'm talking about. We have negative 18 minus 14x is equal to x squared minus 3x. And what I'm really wanting to do is move these two things to the left side. So I'm going to add 18 to both sides and add 14x to both sides. Of course, I'll add the x to the x and the numbers to the numbers if there are any. So we end up with x squared, negative 3x plus 14x is 11x, positive 11x, and then plus 18. And so now I'm going to solve this equation. Now to solve this equation, I just simply factor and set each part equal to 0. X plus 2 times x plus 9. And when we set x plus 2 equal to 0 or x plus 9 equal to 0, we end up with x equal to negative 2 or x is equal to negative 9. Now, as you notice already, x is not allowed to be negative 2. So if we get negative 2 as a solution, then that's an impossibility. And the reason for that is if we try to solve this equation, we plug in negative 2, we'll be having 6 divided by 0 and a negative 2 divided by 0, and that's not allowed. So negative 2 is not allowed to be a solution. So then we check. And I won't be checking with all the questions, but you should do that with your questions when you're doing these. So we're going to check x equal to negative 9. So we try negative 9. We get 6 over negative 9 plus 2 minus 20 times negative 9 over square of negative 9 minus negative 9 minus 6. And then on the right side, we have negative 9 over negative 9 plus 2. So the left side works out to be negative 9 over negative 7, which is 9 over 7. And the right side, we basically are going to combine two fractions here. We have 6 over negative 7. So we have 6 over negative 7, which is negative 6 over 7, plus we have 20 times negative 9 is negative 180. So we have, well, negative times negative is positive, so it's positive 180 divided by, and so we have 9 squared, which is 81, plus 9, because that's plus negative 9, that's 90, minus 6, that's 84. And when we simplify this fraction, 180 over 84, let's simplify that fraction. And we get 15 over 7. And Now that the denominators are the same, you just add the fractions together, the numerators together. Negative 6 plus 15 is 9. 9 over 7 equals 9 over 7. And there we have it. Oh, by the way, if you're wondering how I got this over 7, just divide top and bottom by 12. So, since this works, then our solution then is just negative 9. The negative 2 did not work. Now, in the subsequent questions that we're going to do, I'm going to leave you to check the solutions. Or for most of them, I would probably check a few, but others I want you to check them as well. And as always, try the questions before and see if your answers match with my answers. So, for this question, of course, we know that where x is not going to be allowed to be 0, because then you'll be divided by 0. And the least common multiple of the denominators is 3, 4, and 6 have common multiple 12. And the common variable is x. So we have 12x. So we're going to multiply each term by 12x. On both sides. And since I'm multiplying fractions, I'm going to write 12x as 12x over 1. And then we divide. The x is cancelled here. 3 goes into 12 4 times. 4 goes into 12 3 times. The x remains. The x cancels and the 6 goes into 12 twice. And 3 goes into 12 4 times. So let's see what we end up with. We end up with 2 times 4 is 8 plus 3x equals to 11 times 2 is 22, and then minus 4x. And there we have it. Now we have a simple equation to solve, which is now relatively easy to do. So we combine the x's together, so I'm going to add 4x to both sides. And I'm going to, since that's a linear expression, I can now subtract the 8 as well from both sides. A linear equation, sorry, one variable. So I have 7x is equal to 22 minus 8, which is 14. And so x is now equal to 2. And then, of course, you can check your answer. I'll just show this one quickly. We have 2 over 3 times 2 plus 1 over 4 is equal to 11 over 6 times 2 minus 1/3. Now this is going to be 1/3 plus 1/4. And this is going to be 11/12 minus 1/3. And 1/3 plus 1/4 is 7 over 12, because that's 4 over 12 plus 3 over 12. And 11 over 12 minus 4 over 12 is 7 over 12. I changed the 1/3 to 4 over 12, common denominator, so it works. So our one answer is correct. Let's move on to the next example. Once again, we realize the domain restriction is that x is not allowed to be -3. And the least common multiple of the denominators here is just x plus 3. So we're going to multiply both sides by x plus 3. So we have 5 over x plus 3 minus 2 is equal to 7 over x plus 3. And we're going to multiply each of those terms by x plus 3. And then we'll cancel what can cancel. And then we simplify. We end up with 5 minus 2 times x plus 3. And I'm going to distribute that to that -2 to the x plus 3. So I'm going to get 5 minus 2x minus 6, and the right side is equal to 7. And then we just solve this equation. So we end up with negative 2x minus 1 is equal to 7. So negative 2x is equal to 8, which means x is equal to negative 4. And then we can always just check the answer there. So to check it, we're going to plug in negative 4. So we have 5 over negative 4 plus 3 minus 2 is equal to 7 over negative 4 plus 3. Now, 5 over negative 4 plus 3 is just 5 over negative 1, which is negative 5, and that's minus 2. And 7 over negative 1 is negative 7. And as you can see, those things both work out to be the same thing. So that means my solution is negative 4. All right, continue with examples here. We're going to rewrite this expression as a rational expression. So we have negative 3 over w. The exponent is only for the w, so only on the w gets a reciprocal. And both of them have w as the denominator. So we know that w is not allowed to be 0, and the least common multiple of the denominators is w. So I'm going to multiply each term by w. And then we simplify as usual. Combine like terms when necessary. Negative 3 is equal to 2w plus 1. And then we just solve this equation. Subtract 1 and divide by 2. So we get w equals to negative 2. And to check that one, we're going to go to the rewritten version, because negative 2 to the negative 1 is 1 over negative 2. So we're going to write negative 3 over negative 2 is equal to 2 plus 1 over negative 2. And this is 3 over 2. And that is 2 minus half, another 3 over 2. So that means this answer works. So our solution then is negative 2. Move on to another example here. And now at this point, I'm going to have you check these answers on your own by plugging them in and simplifying. And it would be good to use your calculator in some cases, because some of these may be a little tedious. Let's go through to number 31. So first we factor all the denominators. So I'm going to factor out a 5 here, leaving y plus 2. And then this denominator doesn't factor, so I'll just leave it as y minus 5 in parentheses. And this denominator factors to be y minus 5 times y plus 2. And from here you can see that y is not allowed to be negative 2 nor 5. And the least common multiple of the denominators would be 5 times x minus minus 5 times x plus 2. So I'm going to multiply both sides by that expression. So we have 6, let's see if it will fit here, over 5 times y plus 2, which we will multiply the numerator by the common denominator there. We have 1 over y minus 5. I'm going to multiply by the common denominator. And that's equal to 4 over y minus 5 times y plus 2. So we're now going to multiply by the common denominator. We're going to multiply by 5 times x minus 5 times x plus 2. We're going to multiply each term by that expression. 5 times, I was using x. Oh, my bad. I should have been using y for my variable. So I'll correct that in a minute. So y minus 5 times y plus 2. And again, times 5 times y minus 5 times y plus 2. Let me quickly correct my variable here where I made a little error. Transcription, something you might want to pay close attention to. And then we start canceling. This 5 cancels with that 5, leaving 1. Y plus 2 cancels that y plus 2, leaving 1. Y minus 5 cancels with y minus 5. And y plus 5, y minus 5 cancels y minus 5. Y plus 2 cancels y plus 2. And now we combine, well, we simplify and combine like terms. We have 6 times y minus 5 minus 5 times y plus 2 plus 1 times 5 is equal to 4 times 5, which is 20. And now we distribute, we get 6y minus 30 minus 5y minus 10 is equal to 20. Combining like terms, 6y minus 5y is y. 6y minus 40 equal to 20. So then y is equal to 60. And as I said, I'm going to leave you to check that solution. You can use the calculator. All right, so my solution here is 60. Let's move on to the next one. We are going to factor the denominators. We need two numbers that multiply to be 12 and that to be negative 7. Those numbers are negative 3 and negative 4. Doesn't matter which one you put first, actually. Over here, we need two numbers that multiply to be negative 12 and that to be positive 1. Those numbers would be positive 3 and positive 4 and negative 3. And then on the left side, we factor this, and that's a difference of squares, x minus 4 times x plus 4. So right away we see that x is not allowed to be 3, 4, or negative 4. Those are our restrictions on x. And the least common multiple of the denominators, in LCD, is x minus 3 times x minus 4. And then we'll go over here, there's already an x minus 3 covered, but there's not an x plus 4, so we'll multiply that in. And we'll go over here, there's an x minus 4 covered and an x plus 4 covered. So that's the least common multiple of the denominators. And then we go through the process again, as before. This might be a little bit more tedious, but let's see what happens. Because everything is factored, cancellation will be relatively easy, even though it may seem a little cumbersome when we're writing it. So I'm going to multiply both sides by the common denominator, each term. So we're going to multiply by x minus 3 times x minus 4 times x plus 4. And I'm going to do the same thing here. X minus 3, x minus 4, x plus 4. And over here, x minus 3, x minus 4, x plus 4. And then we are going to start a little cancellation. So let's cancel some stuff here. X minus 3 cancels with x minus 3, leaving 1. X minus 4 cancels with x minus 4, leaving 1. X plus 4 cancels with x plus 4. X minus 3 cancels with x minus 3. X minus 4 cancels with x minus 4. X plus 4 cancels with x plus 4. So when we're done here, we end up with negative 3 times x plus 4 minus 2 times x minus 4 equals to 10 times x minus 3. And I'm going to distribute. We get negative 3x minus 12 minus 2x plus 8, because that's negative times positive, and then equals to 10x minus 30. Combining like terms here, we get negative 5x minus 4 equal to 10x minus 30. So if I subtract 10x from both sides and add 4 to both sides, we end up with negative 15x is equal to negative 26. And then we get x is equal to negative 26 over part negative 15. That's that. X is equal to 16 over 15. And that's our solution. Again, I'm going to leave you to check that answer. And just for the sake of time and space, we won't be able to check it right now. All right. So we're going to move on to the next question. And in this next question, similarly as before, we're going to solve a few equations here. Now, if you notice, when we factor, the first denominator doesn't factor, so we put x minus 2. Second denominator doesn't factor, so we put x plus 2. Third denominator factors as a difference of squares as 2 minus k and 2 plus k. I said x, I meant k. Now, if you notice, 2 minus k and k minus 2 are very similar, and that's because 2 minus k is the same as the negative of k minus 2. So I'm going to rewrite this expression as 3 over k minus 2 minus 5 over k plus 2 plus 6k over the negative of k minus 2. And I'll just rearrange that 2 plus k because that doesn't change anything. K plus 2. Now I'm also going to move this negative to the front of the expression so that now this becomes a negative. The sign changes. So let me just quickly indicate that the sign changes here. And the reason is I rewrote this expression in the reverse order. Now that means k is not going to be allowed to be positive or negative 2, and the least common multiple of the denominators now is k minus 2 times k plus 2. So I'm going to now multiply each term by that common denominator. So we have 3 over k minus 2 minus 5 over k plus 2 minus 6k over k minus 2 times k plus 2 equal to 0. And I'm multiplying everything by the product k minus 2, k plus 2. And of course, we do it to both sides. Then we cancel k minus 2. Oh, let me go back to my standard. And let me just adjust the shading slightly lighter. All right. So we got k minus 2 cancels with k minus 2. K plus 2 cancels with k plus 2. And both of these cancel. And 0 multiplied by anything is 0. So we end up with 0 on the right side. We have 3 times k plus 2 minus 5 times k minus 2 minus 6k on the left side. Distributing, we get 3k plus 6 minus 5k plus 10, because negative 5 times negative 2, minus 6k equal to 0. Combining like terms, we have 3k minus 5k minus 6k, and looks like a negative 8k. And then 6 plus 10 is 16. And so when we solve this equation, you'll see that the answer works out to be 2. However, 2 is not allowed. This is not allowed, because our restricted values says k is not allowed to be 2 or negative 2. So therefore, this actually is not an allowed solution. So there is no solution, no solution. And the shorthand for solution is SOLN. And or we could write it this way, a circle with a slash. That means no solution. So this equation actually has no number that makes it true. There is no solution to this equation. That's one reason you want to make sure you have your domain restrictions to identify when a situation like that occurs. Now let's go on to the next one. We have 3 over b plus 2. b plus 2 doesn't factor, so we put it in parentheses. Minus 1 over b minus 1 doesn't factor, parentheses. Minus 5 over b squared plus b minus 2. That factors to be b plus 2 times b minus 1. And then we see here that b is not allowed to be negative 2 or 1. And our least common multiple for our denominators is b plus 2 times b minus 1. So we'll remember that as we work. So we're now going to multiply the numerator and denominator by the least common denominator. And as usual, I'm going to create a little space here to multiply those things in. And then we multiply by the LCD, b plus 2. Make sure your b doesn't look like a 6 times b minus 1. b plus 2. Make sure you write clearly as well. b minus 1. b plus 2 times b minus 1. And then the left side also gets multiplied by b plus 2 times b minus 1. And then I can start some cancellation. B plus 2's cancel. B minus 1's cancel here. B plus 2 times b minus 1 both cancel there. So we end up with 3 times b minus 1 minus 1 times b plus 2 minus 5 equal to 0. So we end up with 3b minus 3 minus b minus 2 minus 5 equal to 0. 3b minus b is 2b. Negative 3 minus 2 is negative 5, minus 5 is negative 10. So when we solve this, we get 2b equals to 10. All right? So then b is equal to 5. And as we see, we check here. That's not restricted. Can do a quick check here. 3 over 7. When you use 5 for x, and you can do it on a calculator. 3 over 7. And then minus 1 over 4, because that's 1 minus 1 minus 5, 5 minus 1, sorry, and then minus 5 over 25 plus 5 is 30, minus 2 is 28. So it's 5 over 28. You work that out, and you'll see that that works out to be 0. So that means our solution then is just 5. All right, now what we're going to do next is a few questions involving solving for the indicated variable. It's relatively easy. The idea is to get the variable in the numerator and then use PEMDAS to isolate the variable. So we have, for example, want to solve for capital R in this expression. So what we need to do is get that capital R to the numerator. And to do that, we're going to kind of cross multiply. In reality, we're just going to multiply both sides by this denominator. So I'm going to multiply the left side by R plus R, uppercase R plus times lowercase r, and the right side I'm going to multiply by the same expression. And then when I do that, the denominator cancels from the right side, and I can distribute the I to each term on the left side. So we end up with I times R plus I times lowercase r is equal to E. Then I can solve for uppercase R. E minus I times lowercase r. And then divide both sides by I to get the uppercase R by itself. We get E minus IR lowercase r over uppercase R. And that's it. Oh, sorry, over I. My apologies. And some people may have done it another way and gotten the answer E over I minus R. And that's fine. It's the same result. Let's try number 52. Now we have a W in the numerator and W in the denominator. Not a problem. We're going to do the same approach. We're going to multiply in the numerator and the denominator by the denominator. Basically, effectively cross multiplying. Then we're going to get the W's together. And once we do that, we factor them out, factor out the W, and solve for W. In factoring out the W, what ends up happening is two separate W's will become one W. So we end up with W minus N is equal to PWN. Because these guys canceled. Then what I will do is I can do it one of two ways. I'll just subtract W from both sides. Then I factor out the W from the right side. And then I divide both sides by the parentheses. So the answer is either W is equal to negative N over Pn minus 1, or W is equal to positive N over 1 minus Pn. And the reason for that is if you multiply the numerator and denominator by negative 1, the signs of both get reversed. Let's try a couple more. In this case, we want to solve for m. We multiply both sides by m, and you'll get mg. We subtract mf from both sides. We get t equals mg minus mf. And then factor out m. We get m times g minus f. Then divide both sides by the parentheses, and I'm just going to write it in reverse order. We have m over t minus g, t over g minus f. M equals t over g minus f. And that's that. Let's go on to the next example. These are all actually real exercises, real formulas in science and mathematics. So, and mathematics really is a tool for doing other things, particularly science and business. All right, now let's want to get just the r by itself. I can't just flip both sides because this is a plus. So one of the things I can do is combine these two fractions. So the least common multiple of the denominator of the fractions is r1 times r2. So I'm going to multiply the numerator and denominator of this fraction by r2. And I'm going to multiply the numerator and denominator of this fraction by r1. When I do that, I have 1 over r is equal to r2 plus r1 over r1 times r2. Now to get the r by itself, just do the reciprocal. So r is equal to r1 times r2 over r2 plus r1. Let's indicate that we did the reciprocal. And combine fractions. Combine the fractions on the left side, on the right side. On the right hand side, and we are doing that by common denominator, LCD. And this is our answer. And there we have it. These are relatively easy, but you have to practice to get good and efficient at them. So let me just box these in so you can see the solutions. Okay, now the next thing we want to do is solve equations. And when you're solving rational equations, usually they show up, well, not usually, but a lot of times they show up in the form of a proportion, which is just a fraction equal to a fraction. And so we're going to do some word problems, some applications of these, both with proportions as well as with other rational expressions that we will solve. And just remember that when you're solving a proportion, one quick thing you can do, as indicated by the tip here, is to cross multiply. You multiply the denominator of one side by the numerator of the other side, and vice versa. So it's like multiplying the a times the b and the b times the c, and then set those products equal to each other. This only works with proportions, by the way. That's very important. It only works with proportions. It does not work with inequalities, for example. Now let's do a few examples here. It's relatively easy. To solve for the variable, you just, if you have a proportion, a fraction equal to a fraction, you can just simply cross multiply and solve for the variable. And sometimes there's a shorter step by, for example, multiplying by just this denominator and simplifying, and that will give us 4 as our answer. But let's go on to do it the longer way here. 15 times 12 is, I believe, 300. 180, I'm sorry. 15 times 12 is 180. And then when we divide both sides by 45, we get 4. And that's that. It is that easy. And you can always check by seeing if plugging in 4 and see if both fractions simplify to be that. For this one here, we're going to cross multiply again. 9 multiplied by 1 and 49w multiplied by w. So we end up with, let me put the w's first, we have 49w squared equals to 9. I divide both sides by 49, I get w squared equals to 9 over 49. And then I take the square root of both sides. But when I take the square root of both sides, square root could be, when you square a number, you could actually get a positive, whether the number is a negative or a positive. So that means when you do the square roots here, you should get a positive or negative answer. Square root of 9 is 3, square root of 49 is 7. So my answer is positive or negative 3 over 7. So there are two possible answers here. Negative 3 over 7 or positive 3 over 7. Let's go on with this one here. Again, we're going to cross multiply. And in cross multiplying here, I'm going to put the numerators in parentheses so that I remember that I'm multiplying a whole expression. So we end up with 3 times p minus 1, and that's equal to 4 times p plus 3. And then, of course, we will distribute the parentheses and combine like terms. We end up with 3p minus 3 is equal to 4p plus 12. Now, if I subtract 3p from both sides and subtract 12 from both sides, my answer becomes basically p equals to negative 15. And that is our answer. Now, to check if we're right, we just plug in negative 15. Negative 15 minus 1 is negative 16 over 4 is negative 4. And negative 15 plus 3 is negative 12 over 3 is negative 4. So that is the correct answer. All right, now for the sake of space, I'm going to move number 22 to this side and number 20 to this side, because I see that it looks like number 22 will take up a lot more space to do. So we're going to proceed again with this. We're going to cross multiply and then solve the corresponding equation. So we have 2 multiplied by 2y plus 3 is equal to 3 multiplied by y. Distributing here, we get 4y plus 6 is equal to 3y. And of course, subtracting 3y from both sides, we end up with y plus 6 equal to 0. So that means y is equal to negative 6. And that's our answer. And once again, we can check to see if we're correct. 2 times negative 6 is negative 12. Sorry. Yes. 2 times negative 6 is negative 12. Negative 12 plus 3 is negative 9. Negative 9 over negative 6 is 3 over 2. Let's divide top and bottom by 3, simplifying the fraction. So we now move on to the next example here. We're going to do the same process. We're going to put parentheses around the expressions that don't factor. And we're going to cross multiply. Denominator multiplies the numerator, and vice versa. I'm going to put this product on the left side, so we have x minus 3 times x minus 5. I'm going to put that product on the right side, that's equal to 3. And you see here, this looks like it's going to be a quadratic equation. If I distribute by foiling, multiply each term in one parentheses by one pair of parentheses by each term in the other pair, we end up with x squared minus 5x minus 3x plus 15 equal to 3. And I recommend that when you're doing these, by the way, you show all your steps, because if you make an error, it's hard to figure out where the error is in your head. So what you want to do is have it all written down. And once you have it all written down, it becomes an easy process to double check your work. So we end up with x squared minus 8x plus 12 equals 0. We factor, we get x minus, and let's check this out here. Two numbers that multiply to be 12 and add to be negative 8. Those numbers would be negative 2 and negative 6. So we set each part equal to 0. And we solve for the variable. And again, I recommend that you do not rush through this. You show all your steps. Now let's check to see if we're correct. We plug in 2, we get 1 over 2 minus 5 is 1 over negative 3, that's negative 1/3. And 2 minus 3 is negative 1, negative 1/3. Plug in 6, 1 over 6 minus 5 is 1, 1 over 1. And 6 minus 3 is 3, 3 over 3 is 1. So both of those work. So our answer is 2 and 6. Those are our answers, 2 and 6. Now, let's go on to doing a quick application here. Usually these examples can be found in similar figures, and we have 2 sets of similar triangles here that we're going to do. So let's start off. In similar figures, corresponding sides are in the same ratio. So since this corresponds to this, and this corresponds to this, and this corresponds to this, those ratios are all the same. And we can also say 13 over 8 matches up with 13 over 8 matches up with y over 12, for example, or x over 8 matches up with 18 over 12. So let's do those. We have x over 8 is in the same proportion, is in the same ratio as 18 over 12. And at the same time, we know that 13 over 8 is in the same ratio as y over 12. So we can solve those. So now we just cross multiply, or we actually, in this case, just multiply both sides by 8, and this side we just multiply both sides by 12. But I'm going to do the cross multiplying. So we have 12x is equal to 8 multiplied by 18. And 8 multiplied by 18 is 144. So that means x is equal to 12. And in this case, we have 8y is equal to 13 multiplied by 12. And 13 multiplied by 12 is 156, which we then divide by 8. And that will give us 19 and a half. If you divide 156 by 4, you will get 39. And 8 divided by 4 is 2. So my solution then, well, let's just leave it like that. X equals to 12 and y equals to 19 and a half, 19.2, 1.5, 35 over 39 over 2, whichever one of those you can use. Those are all variations or equivalent forms of the same number. Now, we're going to do a number 41 in the same way. We see that x over 5 matches up with z over 1.75. And we see that y over 5 matches up with 4.55 over 1.75. Now, as a quick side note here, this is a right triangle, so you can always use Pythagorean theorem to figure out z. Okay? So if we get stuck, we can always go to the Pythagorean theorem. But you want to set up a proportion so that you don't have more than one variable in the proportion. So if I try to solve for x, for example, I might get stuck because I don't have a way to get only the x in the proportion. But if I'm trying to solve for y, that becomes relatively easy because y over 5 is equal to 4.55 over 1.75 because those sides are in proportion. So let's divide 4.55 by 4.55 divided by 1.75, and that gives us 2.6. So we have y over 5 is equal to, and if you recall, 2.6 is actually 13 over 5. So if I multiply both sides by 5, I will get y is equal to 13. Now that we know that y is 13, we can always find the x very easily by Pythagorean theorem or using a proportion. So we're going to use the fact that y is 13 and put it right here. And then I can set up my proportion saying, well, let's see. We can say, well, apparently we have to do the Pythagorean theorem. So let's do the Pythagorean theorem here. So since it's a right triangle, we do leg squared plus leg squared equal to hypotenuse squared. X squared plus 5 squared is equal to 13 squared. And that means x squared plus 25 is equal to 169. So that means x squared, subtract 25 from both sides, I get 144. That leaves x equal to 12, only positive because these are side lengths. Now, since x is equal to 12, we now can figure out z by either doing another proportion or the Pythagorean theorem again. Let's try the proportion. So we now have that this x is equal to 12. So then for z, let me do it over here, we have 12 over 5 is equal to z over 1.75. If I multiply both sides by 1.75, well, let's see. 1.75 multiplied by 12 is equal to 21. So we have 21 is equal to 5z. Let me write it this way. 5z is equal to 21. And then we divide both sides by 5. And then that, of course, gives you 4.2. So then the answer then is, oh, I neglected to put my units of measurement. They didn't have them there first. So we have x is equal to 12 centimeters and y is equal to 39 over 2 centimeters. So x is equal to 12 inches, y is equal to 13 inches, and z is equal to 4.2 inches. Make sure the units are corresponding to the diagram. Now let's do a few word problems here, and then that will be it for this lesson. Now, of course, with word problems, you need to remember to read the problem, explore it, come up with a strategy to solve the problem, and then test your answer to see if it makes sense. Let's start off with number 29. A fisherman in the North Atlantic catches 8 swordfish for a total of 1,840 pounds. Approximately how many swordfish were caught if a commercial fishing boat arrives at the port with 230,000 pounds of swordfish? Now they're saying approximately, so we're going to just round our answers to an appropriate variable. So we know that 8 swordfish goes with 1,840 pounds. And then we know then that X swordfish will go with 230,000 pounds. And all we need to do is cross multiply. In reality, we don't actually have to cross multiply. Just multiply both sides by this denominator to get the x by itself. So multiplying both sides by 230,000, sorry, we get 8 times 230,000 over 1,840. And that will give us an answer for x, an approximate answer. So we do 8 multiplied by 230,000, which I am doing on the calculator here. And then we divide that answer by 1,840. And that answer works out to be 1,000. So therefore, the commercial fishing boat caught approximately 1,000 swordfish. Biggest challenge in doing a lot of these questions is setting up the equation for you to solve. So the only way to get good at these questions is by doing a lot of practice. It's the only good way of getting good at mathematics. It's by a lot of practice. Now, Pam drives her Toyota Prius 243 miles in city driving on 4.5 gallons of gas. At this rate, how many gallons of gas are required to drive 621 miles? Again, relatively simple. You know that 4.5 gallons corresponds to 243 miles. And then we don't know how many gallons, but that corresponds to 621 miles. And again, you can just cross multiply or just simply multiply by the denominator here. So I'm going to do that. X is equal to 4.5 multiplied by 621 and then divide by the 243. And let's see what that gives us. I'm going to do this on the calculator here. 4.5 multiplied by 621 and then divide by 243. And that gives us 11.5. So the answer is 11.5 miles. So, I should say approximately 1,000 swordfish. So let me just make a quick adjustment here because we're answering the question that they ask. They're not asking for a variable. So in this case, our answer here is, sorry, not miles, gallons. So answer is 11.5 gallons. That is what she will need. Now let's go on to the third example. And again, I recommend that you do these examples on your own and then check them with my work. The ratio of men to women accountants in a large accounting firm is 2 to 1. If the total number of accountants is 18, how many are men and how many are women? So this one is a little trickier. They're asking about the total. So men over women is equal to 2 over 1. But they don't say the ratio of men to women, they say the total number of accountants. So let's do it this way then. That means men to the total would be the same as 2 to 2 plus 1, which is men to total is 2 to 3. Based on that idea then, we can then say, if we say M is the number of men, M over the total of 81 people is the same as 2 over 3. And then if I multiply both sides by 81, we get 2 over 3 times 81. And 2/3 of 81 is 54. So therefore there are 54 men. And that means there's half as many women, which would be 27. So the answer to our question is 54 men and 27 women. And you can easily check, just add the number of men and women and you'll see that's 81. And you'll see that 54 is twice as many as 27. Let's go back up a little bit so you can see, or you can pause the video. Now, let's move on to the next few examples, and then we'll call that the lesson. A bicyclist rides 24 miles against the wind and returns 24 miles with the wind. His average speed for the return trip is 8 miles per hour faster. If x represents the bicyclist's speed going out against the wind, then the total time required for the round trip is t equal to 24 over x plus 24 over x plus 8. How fast did the cyclist ride against the wind if the total time of the trip was 3.2? So if you notice this, they're basically giving us a very simple process here. The time is 3.2. So we have 3.2 equals to 24 over x. That would be the time going against the wind, and with the wind, and the time going against the wind. This is the time going against the wind, and the time going with the wind is 24 over x plus 8, because the time going with the wind is shorter than the time going against the wind. And the 3.2 is the total amount of time taken. All we have to do then is just solve this equation for x. Well, we know that x is not going to be allowed to be 0 or negative 8, which the speed could not be a negative. It's a positive speed. So we know we're not going to get either of those. You want 0 speed means you're not moving. Negative 8 means you're going backwards, or actually that would be velocity, but there's no negative speed. So the only thing we have to do is make sure we get a positive answer. Now what we're going to do is find the least common denominator. And as you can see here, the least common denominator, if I rewrite 3.2 as a fraction, that might actually give us a little better denominator. 3.2 as a fraction would basically be 16 over 5. So I'm going to write this as 16 over 5. And that is the 3.2 hours. So my least common multiple of denominator is 5 times x plus 8. So now I multiply both sides by the least common multiple of the denominators, and then it becomes a simple process to solve this equation. Now, let's move on to see what this simplifies to be. So, the 5, of course, cancels. The x cancels, and the x plus 8 cancels. I'm going to put that x plus 8 in the denominator here in parentheses. Now, we end up with 16 times x plus 8 is equal to 24 times 5 is 120. So we have 120 times x plus 8, and then times 120x. And then let's distribute. We have 16x squared plus, and 8 multiplied by 16 is 128. So we have 128x is equal to 120x plus 120 multiplied by 8. It's going to be 960 plus another 120x. What we have here is a quadratic equation. So what we're going to do is get everything equal to 0. So we have 16x squared plus, well, we're going to subtract 240 from both sides. So 128 minus 240 You can do that in your calculator. You get negative 112. And we're going to subtract 960 from both sides as well. Now, let's check to see if we can divide everything by 16 here and see what happens if we do that. Well, 960 doesn't get divided by 16 because 960 is not a multiple. Well, let's check. 960 divided by 16. Yes, actually, it does get divided. So if I divide everything by 16, I get x squared. And 112 divided by 16 is 7. And 960 divided by 16 is 60. And then I just solve this equation by factoring. We need two numbers that multiply to be 60, negative 60, but when we add those two numbers, we get a negative 7. And we see that those numbers are positive 12 and negative 5. Oh, pardon me, negative 12 and positive 5. And we solve that, we get x minus 12 equal to 0, or x plus 5 equal to 0. And then we see then that means x is equal to 12, or x is equal to negative 5. Since this is speed, speed cannot be negative, all right? So since speed cannot be negative, we're going to say that speed cannot be negative 5. So then that leaves us with the answer of 12 miles per hour. So the bicyclist was going 12 miles per hour when they're going against the wind. Okay? And it says, how fast did the cycle ride against the wind? So the answer to this question, cyclist rode 12 miles per hour against the wind. And that's the end of that question. And you can always check through and verify. Now let's go on to the next example. And it says one painter can paint a room in 6 hours. Another painter can paint the same room in 8 hours. How long would it take to do for them working together? So they want to find the time working together. Let's call that time working together T. Find time working together. And let's call that T. Now, I want to point out something here. With a question like this, and when you see these type of working to the questions, I recommend that you focus. Let me put a little note here. Focus on amount done per unit time. In this case, per hour. So we're going to ask, how much do they do in 1 hour? So we have two painters here. What we're going to do to help us to organize the information, we're going to do a table. All right, we're going to have painter number 1, painter number 2, and both of them working together. Now, again, with word problems, you want to practice doing these so you get the hang of them. When I'm doing this stuff here, it looks easy because I have the experience with them, but you only get good at word problems by practice. So time to complete job. And the amount done per unit time in 1 hour. And I'll tell you why in a minute. When we're looking at them working together, the amount that both of them do in 1 hour together is actually the amount that each of them does by themselves added together. So whatever one person does by himself plus whatever the other person does by himself in 1 hour is the amount that they both do together in 1 hour. So we can get an equation from that. But we have to think about this process very carefully, because there's another little thing we have to think about with that. So we know that one painter does it in 6 hours. So I'm going to call that 6. I'll just put 6 hours. And the other painter takes 8 hours. Now we recognize then that the time working together, which is T, should be actually less than either one by himself. So your answer should be smaller than 6. Now, if it takes painter 1 6 hours to do the one job, how much of the job has he done so far in 1 hour? He's not done the whole job. He's only done 1/6 of the job. So 1/6 of the job is done in 1 hour by painter 1. And 1/8 of the job is done in 1 hour by painter 2. And if you're looking at both of them together, I do the same process. I divide by the amount of time it would take them to do the whole thing. And it means then when I add how much painter 1 does in 1 hour to how much painter 2 does in 1 hour, that will give me how much they both do together. I just multiply both sides by the common denominator, which in this case is 24t. So I'm going to multiply 1/6 and 1/8 and 1/t by 24t. Because that's the common denominator. And when I simplify those, I end up with 6 into 24 is 8. So we have 8t. 8 into 24 is 3. So we have 3. Oh, 6 into 24 is not 8. 6 into 24 is 4. 4t plus 3t equals to 24. And of course, 4 plus 3 is 7. So we have 7t is equal to 24. So that means t is equal to 24/7. So that means, working together, they take 3 hours and 3/7 of an hour, 3 and 3/7 of an hour to do the job. And the 3 and 3/7 is by simplifying, writing the improper fraction as a mixed number. And there you go, less than either one of them. All right, so let's go back to, this was a question from an earlier section, but it's relatively easy. 7 is decreased by the reciprocal of a number. So we're trying to find the reciprocal of a number. We're trying to find a number, and we know that when we decrease 7 by that, by the reciprocal of the number, we get 9/2. So I start off with 7, and I decrease it by the reciprocal. 1/x is the reciprocal of the number. And when we do that, we get 9/2. So then all we do is just multiply everything by the common denominator, which is 2x. So we're going to do 7 times 2x minus 1/x times 2x is equal to 9/2 times 2x. And when I simplify that, I get 14x minus 2 is equal to 9x. And that means I subtract 9x from both sides, and that gives me 5x. And I add 2 to both sides, that gives me 2. So that means my number here is x is equal to 2/5. And let's check to see what happens there. If I take the reciprocal of 2/5, I get 5/2. And then if I do 7 minus 5/2, I do get 9/2. So that means this is the answer. 2/5 is the answer. That's the number that I'm looking for that fits the description in the question. Let's do one more of these. If a number and its reciprocal are added, the result is 13 over 6. Find the number. So we're saying that if the number is x, its reciprocal would be 1 over x. And when you add them together, you get 13 over 6. So we're going to solve this equation. We're going to multiply both sides by the least common denominator, which is 6x. So I'm going to multiply 6x to each thing here. So I'm multiplying x by 6x. I'm multiplying 1 over x by 6x. And I'm multiplying 13 over 6 by 6x. Now, x times 6x is 6x squared. And then the x's cancels here, leaving just 6. And the 6's cancel here, leaving just 13x. So what we have here is a quadratic equation, 6x squared plus 6 equal to 13x, which I'll move the 13x to the left side. So I get 6x squared minus 13x plus 6 equal to 0, which we can now solve by factoring. We multiply 6 by 6, we get 36. We need two numbers that multiply to be 36 and add to be negative 13. Those numbers are negative 9 and negative 4. So we have 6x squared minus 9x minus 4x plus 6 equals to 0. And then we factor that by grouping. Common factor here is 3x. That leaves 2x minus 3. And then we drop that negative down. Common factor is 2. So we have 2x minus 3. Negative, positive divided by negative is negative. And then we complete the factoring. We end up with 2x. Well, let me write it down here. 2x minus 3 multiplied by 3x minus 2. So we end up with either 2x minus 3 is equal to 0 or 3x minus 2 equal to 0. We solve these, we get x is equal to 3 halves or x is equal to 2/3. And now, if you think about it, that makes sense, because if we add a number to its reciprocal, if one of these is the number, then the other number is the reciprocal. So both of them could work. And if we try them, if we add 2/3 plus 3 halves, you will get 13 over 6. Let's get a common denominator of 6. You'll get 4 over 6 plus 9 over 6 will give you 13 over 6. So that's our answer right there. Now let's go through our last set of examples. Brooke walks 2 kilometers per hour slower than her older sister Adriana. If Brooke can walk 12 kilometers in the same time that Adriana can walk 18 kilometers, find their speeds. And now remember this is a speed problem, so we know that the distance is equal to the rate multiplied by the time. And so if they're walking in the same amount of time, what we might want to do is get a form to an equation where the time is the same. So I can rearrange this formula for the time by dividing both sides by r. So the time is just the distance divided by the rate. So let's say Brooke's speed is r. Brooke's speed is r. I don't want to use s because that looks like a 5 too much. And so if Brooke is going at a speed of r, then that means her sister is going 2 kilometers per hour faster than she is. So because Brooke is slower than her sister. So Adriana's speed would be whatever Brooke's speed is plus 2 miles per hour. All right, let me just write equals here so we can see that more clearly. Now, let's see what we can do with this. The total distance that Brooke travels is 12 kilometers. And Adriana's distance is 18 kilometers. And we know that their times are the same. They have the same time. So for Brooke, the time t is equal to distance over rate. And for Adriana, the time t is equal to distance over rate. And as we said, they have the same time. And that means 12 over r is equal to 18 over r plus 2. This becomes a relatively simple procedure now. We just cross multiply and solve for the r. So we end up with 12 multiplied by r plus 2 is equal to 18 multiplied by r. And let me just continue it over here. So we have 12r plus 24 is equal to 18r. And then we just solve for r. So we have 24 is equal to 6r, which means r is equal to 4. So Brooke's speed is 4 kilometers per hour, and her sister's speed is a little faster. So Brooke's speed is 2 kilometers faster than Brooke. So Brooke's speed is 4 kilometers per hour, and her sister's speed, Adriana's speed, is 6 kilometers per hour. And there you have it. Question seems a little simple, easy to solve. And again, that's because I've done it with a lot of practice. All right, so let's go on to the next question here. So I made a little note here that I wanted to uncover to show to you. Gus works twice as fast as Sid. Together they can dig a garden in 4 hours. How long would it take each person to work alone? Now, since Gus works twice as fast as Sid, that means Sid's time is twice as long as Gus's time. The one who works twice as fast takes less time, half as long. So what we're going to do is find Gus's time, and then we can find Sid's time from that. Sid's time is just double Gus's time. So let's call Gus's time t. That means Sid's time would be double that, 2t. All right. Now, using the idea from the previous question, we want to focus on the amount of time it takes to do, how much they do in 1 hour. So how much do they do in 1 hour? Gus does 1 over t of the job in 1 hour. Sid does 1 over 2t of the job in 1 hour. And together they do 1/4 of the job in 1 hour. All right, so this is the amount Gus, this is amount well, this is the amount done per hour, amount done in 1 hour, in 1 unit of time. This is for Gus, this is for Sid, and this is together. And as in one of the previous examples, the one with the table, we see that you can go through that. So this is a simple equation to solve now. We simply multiply by the common denominator, each term by the common denominator, and then solve the resulting equation. So we have 4t times 1 over t plus 4t times 1 over 2t equals 4t times 1 over 4. And simplify the fractions. The t's cancel. 2t goes into 4t, leaving 2, and 4 cancels. So our answer then becomes 4 plus 2 is equal to t. So t is equal to 4. And so we can then say Gus takes 4 hours. And, 6 is my error. Gus takes 6 hours, and Sid takes twice as long, so Sid takes 12 hours if they were working alone. And that's it. Now, this is the end of our lesson. I encourage you to practice more of these. The only way to get good at word problems is by practicing word problems. That's the same with all things. To get good at them, you must practice. So practice solving these equations, doing these word problems, and review and practice. Review and practice. As always, I recommend you do some questions on Khan Academy. You can also find additional exercises on openstacks.org. And you can check out an intermediate algebra or college algebra book there to give you some more practice. That's all for this lesson. All the best, and keep practicing.